Welcome to another deep dive. Today we're taking a look at something a little different. Yeah,
Okay.
we're going deep on an element.
Oh, wow.
Tantalum.
Tantalum.
Okay, I've heard of it. I've definitely heard of it, but
You've heard of it? Okay.
yeah.
But I'm willing to bet most people haven't. And it's so interesting. We've got the Wikipedia article all ready to go,
Awesome.
and we are going to see just how amazing this element is. Tantalum.
Right.
For those of you who are, working on a school project maybe,
Right.
or have to give a presentation at work, or just like to learn new things, stick
Yeah.
with us. It's going to be a good one.
It's interesting. Most people haven't heard of tantalum, but it's in so many things that we use every day. It's really quite fascinating.
Yeah, it's kind of like a hidden hero of the periodic table.
That's a great way to put it.
So let's start with the basics.
Mm-hmm.
How was this mysterious element discovered? Well, back in 1802, a Swedish chemist, Anders Eckerberg, isolated tantalum. But the interesting thing is, it actually took decades for scientists to confirm that it was a distinct element.
Mm-hmm.
It was very often confused with another element called niobium, which is very similar chemically.
Okay, so it had a bit of an identity crisis
Yeah,
early on.
exactly.
And speaking of identity, where does that name even come from? Tantalum. I mean, it sounds very mythological.
It is, yeah, it comes from Greek mythology.
Yeah.
Tantalus, figure from Greek mythology. He was punished by basically forever being tantalized.
Right.
He was close to food and water, but could never actually reach it.
Oh, wow. So I see the connection. And get this, tantalum itself, it was really difficult to isolate in the beginning and get it to react with anything.
Yeah.
So it was almost like it was reaching for a bond, but couldn't quite get there.
Exactly.
Yeah.
I love that. It's really cool how the name ended up reflecting the element's behavior
Yeah.
and that initial resistance.
Mm.
That actually leads into some of the useful properties of tantalum, like its resistance to corrosion.
Okay. So it's tough to work with, but super resilient once you get it there.
Yeah.
Let's dive in. What makes it so special? What are the properties of tantalum?
Well, for one thing, it's incredibly dense.
Yeah.
To give you an idea, it's more than twice as dense as iron.
Mm.
So imagine holding a piece of tantalum, say the size of a baseball.
Yeah.
It would be extremely heavy.
Really?
Very dense.
Wow, that's dense. Okay, what else?
It also has an incredibly high melting point,
Okay.
over 3,000 degrees Celsius.
Oh.
Only a handful of elements on the entire periodic table can withstand more heat than that.
So it's a tough cookie.
It is. And here's another amazing thing. Tantalum is practically immune to aqua regia.
Aqua regia, remind me what that is again?
Aqua regia is a mixture of nitric acid and hydrochloric acid, and it's extremely powerful.
Okay.
It can dissolve gold,
Wow.
but tantalum, it just kind of shrugs it off.
It laughs in the face of acid. I'm starting to see why this is so valuable. So it's dense, it's tough, laughs at acid. Anything else?
Well, this might surprise you, but tantalum can actually exist in two different crystal phases,
Okay.
alpha and beta.
2 phases. Okay, explain.
So most of the tantalum that we encounter and use is in the alpha phase,
Okay.
which is ductile and can be shaped.
Okay.
But the beta phase, which is much less common, is extremely hard, almost like diamond.
Oh, wow. So it's got like a softer side and a super tough side.
Exactly.
That's pretty cool.
It is. And those different phases open up possibilities for different applications of tantalum.
Okay, I'm just dying to hear about these applications.
Yeah.
But before we go, you had mentioned something earlier about a tantalum isotope.
Yes.
You said it was incredibly rare.
That's tantalum 180 meter.
Okay.
This is where things get really interesting.
Oh, okay.
This isotope is so rare that, in fact, it is thought to be the rarest naturally occurring isotope in the entire universe.
The rarest in the universe.
The rarest in the universe.
Wow. That's mind-blowing.
And on top of that, it exists in a state called a metastable state.
Okay.
So it should decay. It's predicted to decay, but scientists have never actually observed it decaying.
So it's like this tiny little time capsule from the beginning of time, just holding on to these secrets.
Exactly.
I love that. All right, so we've covered the origins. We talked about the name, the properties. Now let's talk about what we actually do with it. Where does it show up in our lives?
That's where things get really exciting. Because tantalum has so many unique properties. It's useful for a lot of different things.
Yeah.
But I think the most well-known use is in electronics.
In electronics. Okay, so tell me more about that. How does it get into our phones and our computers?
Tantalum capacitors.
Okay.
These tiny little components that are vital for storing electrical charge are found in pretty much every single electronic device that you can think of.
Wow. So it's literally like at the heart of our digital world. Pretty impressive for something that most people haven't even heard of. But it's not just electronics, right? You had mentioned other
It's
applications.
not just electronics. Tantalum is also used in superalloys.
Okay.
Because of its strength and its high melting point, it can be used in some of the most extreme environments you can think of.
Okay, now we're talking. Give me some examples. Where do these superalloys come into play?
Jet engines,
Okay.
nuclear reactors,
Wow.
rocket components, anything that needs to withstand incredibly high heat and pressure.
So from smartphones to spaceships,
Yeah,
this element really does get around.
it does.
But there's one more application that I always think is so cool. Medical implants.
Yeah.
How does tantalum end up inside the human body?
Well, tantalum is incredibly biocompatible,
Yeah.
which means it doesn't react with the body's tissues.
Yeah, okay.
And it's also very resistant to corrosion.
Gotcha.
So it's great for things like bone implants or even sutures.
So it's literally helping people heal and live better lives.
That's awesome.
All right, so we've got electronics, superalloys, medical implants, anything else? Any other surprising uses for this element?
Well, tantalum oxide is sometimes used in specialized camera lenses.
Oh, really?
Yeah,
Okay.
because of its high refractive index.
High refractive index, that's one I don't know. What does that even mean?
It means that it can bend light really effectively.
Okay.
So that means you can make camera lenses that are thinner and lighter and produce sharper images.
Oh, okay. So tantalum's helping us capture those amazing photos and videos. I
Yes.
never would have guessed that.
That's pretty cool.
Speaking of tantalum oxide, that's actually derived from a mineral, coltan,
Yes.
which we touched on a little bit before, and this is where things get a little bit serious.
Yeah.
Because coltan is a major source of tantalum,
Yeah.
and a lot of it is mined in the Democratic Republic of Congo.
That's right.
And the mining industry there has faced some really significant challenges. We had mentioned that tantalum kind of has a dark side when it comes to its sourcing.
Yeah.
Can you elaborate on that a bit?
The demand for tantalum, mostly driven by our reliance on electronics, has contributed to conflict and instability in the region.
Yeah.
So it raises some questions about responsible sourcing and ethical implications of using tantalum,
Yeah.
of our technology choices.
It's a complex issue.
Very complex.
And there's no easy answers, but as consumers, we can at least try to be aware of where the materials in our devices are coming from and make informed choices.
Absolutely. And there are organizations that are promoting ethical mining practices.
Okay.
And as consumers, we can choose to support companies that are prioritizing transparency and sustainability in their supply chains.
That's a good point. It's a good reminder that every little purchase we make can make an impact. And we can try to use our purchasing power to support a more, ethical and sustainable future. So let's shift gears a little bit back to the science side of things. I'm curious about the process of actually getting tantalum from coltan. It seems like it would be pretty complex.
Yeah, it is. It's a multi-step process that requires some pretty sophisticated techniques.
Okay.
It starts with crushing the ore and separating the tantalum-rich portions from the rest of the ore.
So you've got this crushed up ore. What's next? How do they actually isolate the tantalum?
Well, the next step is to separate the tantalum from the niobium,
Right.
because as we said before, they're very similar chemically.
Yeah.
So this is where they use hydrometallurgy.
At the metallurgy, what is that?
It involves using a bunch of different acids and solvents to selectively dissolve and separate the different elements.
Okay.
It's a complex process, but it allows for the production of very high purity tantalum,
Okay.
which is what's necessary for a lot of its applications.
So it's like a really high-tech version of alchemy, carefully separating out and purifying these elements.
Exactly.
It's amazing what scientists and engineers can accomplish.
It really is. And there are even newer techniques being developed all the time, like the FFC Cambridge process,
Okay.
which uses electric current to extract tantalum from powdered oxides.
Oh, wow. So instead of heat and chemicals, they're using electricity.
Exactly.
That's pretty innovative.
Yeah. And this method could potentially be more environmentally friendly
Okay.
and efficient than traditional smelting techniques.
So we've got this incredibly versatile element. It's extracted through these amazing processes. We use it in everything from our phones to life-saving medical devices. It's mind-boggling.
Yeah, it's pretty remarkable. And remember that mysterious tantalum 180 metan isotope. Who knows what secrets it holds?
Yeah.
Maybe it will be the key to unlocking some incredible new applications in the future.
That's amazing to think about. All right, so we've covered a lot today. We talked about the history, we talked about the properties, the applications. We even got into some of the ethical considerations of sourcing tantalum. What a journey.
It has been a great journey. But before we wrap things up, I'm curious. It has been a great journey. But before we wrap things up, I'm curious. We've talked about tantalum in these big, important applications, but is there anywhere we might encounter it just in our everyday lives?
Ooh, good question. I mean, it's not like we're carrying around chunks of tantalum in our pockets.
Right. But you might be surprised to learn that tantalum is often kind of hidden in plain sight in some pretty familiar objects.
Okay, I'm intrigued. Spill the beans. Where can we find this stealthy element?
For example, did you know that some high-end watches actually use tantalum in their cases or bezels?
Really? I never would have thought of that.
Yeah, it makes sense when you think about it. Tantalum's durability, scratch resistance.
Yeah.
It makes it perfect for a watch that's designed to last a long time. And plus, it has this really unique bluish-gray color that kind of gives it a sophisticated look.
Oh, okay. So next time I see someone sporting a sleek, expensive watch, I'll have to wonder if there's some tantalum hiding in there.
Exactly. And here's another one that might surprise you. Camera lenses.
Okay.
Some specialized lenses use tantalum oxide in their glass formulations.
Wait, so tantalum's helping us capture those amazing photos and videos.
Yeah,
That's pretty cool.
it is. And it all goes back to those high refractive indices we were talking about.
Yeah.
Tantalum oxide just bends light really well, so it allows for the creation of these really thin and light lenses that can still produce really sharp images.
I'm learning so much about this element. It seems like it's everywhere once you start looking for it. Any other hidden tantalum hotspots we should know about?
Well, this is one for the future. But researchers are even exploring the use of tantalum in 3D printing.
3D printing. Wow, that's cutting edge. How does that work?
Well, tantalum's high melting point and its strength make it a great candidate for creating really durable and really complex 3D printed components.
Okay.
So imagine being able to print lightweight, super strong parts for airplanes or cars or even medical devices.
Yeah.
The possibilities are pretty amazing.
It's incredible to think about how far tantalum has come, from this like ancient myth to these futuristic applications.
It really is. So to circle back to our original question, just how amazing is tantalum? I think we've answered that today.
I think we have. It really is a testament to the power of, scientific curiosity and ingenuity, how we can take something like this element with these really unique properties and use it to create things that benefit humanity in so many ways.
Absolutely. And it's also a reminder that we need to be mindful of the impact our choices have on the world around us.
Yeah.
We have a responsibility to make sure that we're sourcing and using tantalum in all resources, really in a way that's sustainable and ethical.
Well said. This deep dive has been an incredible journey. From the ancient myths surrounding tantalum to its potential to shape the future.
And I hope it's left our listeners feeling inspired and curious to learn more about the world around them.
Me too.
Yeah.
So to our fellow knowledge seekers out there, keep exploring, keep asking questions, and keep diving deep.
Until next time.